Hello everyone from the Novedge team. Welcome to today's webinar, Cast Designer Makes Better Casting. Throughout this webinar, you'll learn what is Cast Designer and how Cast Designer brings benefits to the casting industry, from casting part analysis to gating system design, from simulation to optimization. Our webinar presenter, Dennis Chow, is the Engineering Service Director of C3P Hong Kong and China. He has 13 years of experience in the CAE software industry and 10 years of experience in casting process simulation. Before we get going, here's an overview of what we do at Novedge. Novedge is one of the largest online stores for design software, and we offer a huge assortment of software solutions that cater to virtually every designer's need. Come visit Novedge, novedge.com, and just browse through our huge catalog. And for more daily software news and promotions, pay a visit to the Novedge blog and follow us on Facebook, Google+, and Twitter. Coming up next week, introducing V-Ray for SketchUp, new release, V-Ray 3.0. And last but not least, today's webinar is being recorded, and if you want to rewatch it, you can just go on the Novedge YouTube channel and Vimeo channels to watch it over and over again and spread the word. And now, without further ado, I'm going to pass the screen to Dennis, and he will tell you all about Cast Designer. We're very excited because this is a new product for Novedge, and we have a lot of engineers that are customers, and it's good to expand in the engineering department. I can see your screen now. Take it away, Dennis.
Okay. Hi, everyone. It's Dennis Chow from CFD Solver, the Engineer Service Director. And I'm going to show you about the casting products of CFD Solver. The name is Cast Designer. Cast Designer is a software that focused for casting industry. And this is, we could call it a full engineering solution for casting industry. So let's take a look at what we can do in Cast Designer. And Cast Designer is fully covered the entire casting industry in 5 steps. The first one is about the first step is about the 3D part DFM checking. The DFM means the design for manufacturing. Most of the time, we need to find out some information about the casting product. So we could use this module, the Geo-Designer, to check about the casting part. And the second step is about the quotation. Because if you want to make a manufacturing of a casting part, you need to make a calculation about the cost. So the quotation module helps us to find out the cost of the casting part, and then you could get a quotation report by the software. And the next one is about the gating system design. Gating system is very important in the casting industry, especially in HPDC industry and also the gravity casting industry. We integrate a gating system design module in the software, helping you to build a gating system in a very short time and in a very high quality. And then we could come to the simulation module. This is about the CAE analysis. This module helps us to find out what about the quality of the casting parts during and after the manufacturing process. And if you have more optimized method for the manufacturing, you could try out in the simulation again and again to find out the best solution. And then in the manufacturing process, we provide a module we call the production in Cast Designer. This is a module help us to make a optimization about the cycle time in this module. So this is the full workflow in Cast Designer and also in the casting industry. Now let's take a look at the first one. This is about the DFM analysis, design for manufacturing. In this step, we have a module, Geo-Designer. So let's take a look at what we can do for the Geo-Designer. This is the Geo-Designer. What we can do is we could check about the wall thickness. We could check about the core. Where is the core located in the casting part? We could check about the draft angle, the fill-in radius. We could check about all those kind of information such as slider checking, ejection force distribution, and the riser and gates. Based on this kind of information, we could make a full evaluation about the casting parts. We still provide another two important functions we call the mass distribution index, and another one is a heat distribution index. So the mass distribution index helps us to find out where is the most thickest area, and this kind of area should be risky of solidification, risky of shrinkage porosity during the process. And heat distribution index works the same thing. Okay, now let's take a look at something, Geo-Designer in actions. We could do the Geo-Designer analysis in 3 steps in just 1 minute. The first step is to load the step file or the IGS file or the step STL file. And the second one is automatically mesh the model. This is finished in a very short time. And then we could check the geometry properties such as the MDI, the mass distribution index, the HDI, the heat distribution index. And based on this kind of a process, in just 1 minute, so you could predict 90% of the shrinkage porosity risky in this kind of okay, let's come back. We could predict 90% of the shrinkage porosity in just 1 minute. So that's very easy to use. You don't have to make a simulation. You just check the casting part and you get the results as soon as possible. Okay, this is a real case, what we have done in Geo-Designer. In this case, you will find out an X-ray photo. In these pictures, there was 9 regions have some problems about the shrinkage porosities, and we could use the Geo-Designer to predict this kind of a problem in just 1 minute. So we just mesh the model and check the MDI. You will find out all those problem is generated by the mass, which means if there is a mass in this region, there will be more heat and there will be more risky about the solidifications. So this is what we can do in Geo-Designer in a real case. And the second case is an engine block. The engine block is manufactured by gravity casting industry. And the most important step, and it's always the first step, is about the riser design. Because we should find out where to place the riser. Because the riser should be placed at near the most thickest area, which is useful to fit the metal during the solidification process. So we could use the MDI checking to find out which is the most risky area. We could place the riser on top of that area, and that's very convenient way to find out the right place for the risers. And then we could check about the riser size. If the size is bigger or smaller, if it's enough to fit the metal in Geo-Designer. Okay, and this is another 2 functions in Geo-Designer. The first one is about ejection force. Ejection force is used for the ejection force calculation is used for HPDC, those kind of die casting industry. And you will notice that when the die is opening, the mold locking force is not distributed balanced. Some place here mold locking force and some place with lower. So we need to find out which area should be with higher ejection force. So in this picture, you will notice that here, let me take a look. In this picture, you will find out some red-colored area, which means in this kind of area, we need to apply higher ejection force. And if the area with blue color, which means this kind of place should be with lower ejection force. So this is very useful to for the engineer to design the ejection pane, and that's very useful at the beginning of the design steps. And the second function is about the slider zone. For some complex casting products, there was a lot of cores and sliders should be placed in the mold. So you need to carefully checking about that the slider and cores, because the slider or the core's movement direction is not the same with the die opening direction. So we need to find out all those kind of a place. And so when you find out a core is located, and it will be colored in red, and that will help us to check the model in a very convenient way. Okay. Now let's take a look at the second function we call the quotation prepare. Okay. So for most of the factories, when you receive a customer's order, have a yearly volume, a batch volume, you will have some this kind of order. And the second is you need to calculate the cost. The cost including the manufacturing costs and operation costs, such as the material cost, the machine cost, the manpower, and the storage cost and management cost, all those kind of costs. You could use this kind of use the calculator in CAD Designer to find out the total cost, and you could just calculate the profits revenue for this order. And when you finish the calculation, we could help we could generate a quotation sheet in Excel file format. It'll look just like the left picture. So you will find out what about the cost, and you could of course cost currency, the alloy, the machine, and the manpower cost, all those kind of information. And you could of course to export those kind of a sheet in a multi-language format. So this is what we could do in the quotation module. Okay, now let's move on to the gating system. Gating system is quite important because it is really critical for the filling process. So in a traditional way, we all notice that all the experience are stored in your brain by the engineer. It is not stored in the software. So some of the most of our experiences are in Excel file or in a paper. But on the other hand, for example, when you are doing the design job in PDC, in Unigraphics or in SolidWorks, there was no any casting parameters. So you cannot transfer those kind of key parameters in design, in casting design, to the CAD platform. So that's a question. We always forget about something. That's why we could not do a professional gating system design in the traditional way. So let's take a look what we can do in CAD Designer. We provide a casting design advisor in the software. We finish the design job in 8 steps. So the first step is about the casting information. We input the casting, the metals type, material type, what about the mass or the volume, what about the average thickness about the casting part, and then we could estimate about the gating and overflow. For example, the gating system is about 50% of the casting, the overflow is about 20% of the casting, and then we could find out the total volume of the casting part, of the casting part and also the gating system. And then we could go to find out a casting machine in our database to find out if this kind of a machine is enough to produce those kind of a product. You can select the machine's tonnage and you find out all of the information about casting. And after that, we could assign, helping you to assign where to locate the inner gates, how many ingates you need to place, and what about the section area of each ingate. And after that, you could calculate about the total speed-up ratio from the sprue to the final ingate. This is about the total speed-up ratio. And after the total speed-up ratio, you could design about the gate and the runner. For example, if you have two runners, you just place two runner in the software, and all those sections will be controlled automatically. And then you could build a sprue and sprue runner by a template. You just fill some parameters in the form, and then those kind of sprue will be generated in a very short time. And after that, you could merge, or you could make a Boolean operation of all the components together to make them a complete casting, make a complete gating systems. And then you could do some tuning, such as make some feed radius on the shop edge. So this is about the total steps in CAST Designer to finish a gating system. Now let's take a real case to find out how we finish the design job. The first step is happen here. You get a casting part, and then you throw this part into the Geo-Designer and find out about the MDI, the mass distribution index, and you will find out some place with higher risky of shrinkage porosities. Okay, and then you could make a gating system concept design. You draw some lines and find out if this works for this kind of product. And after that, you could build a gating system and check about the PQ2 diagram. When you select the machine, you will find out the PQ2 diagram if it's proper for the manufacturing process. If it is not, then you change a machine and check again. And then we could finish all the gating system. You will like that the different gates and different runner is with different color. And then finally you could just merge them together. And of course you could add some overflows at the end of the fitting area, like this picture. So this is the full cycle of gating system design in CAST Designer. We still provide another module in phase 6. So we call it free design. Free design is a very convenient way to help you to draw the curves about the gating system. So the first step is to import the casting part, and then you build a reference plan, and you can working on this plan. So you will notice that we provide some functions like build a runner's curve. We build a main runner's curve. We build a spruce curve. Those kind of templates is very useful here. You could draw the line and you could control the points to modify those kind of the curve, and in a very convenient way. Drag and drop, and then you will get the concept design. So, and then we could transfer the speed up ratio into this kind of concept design. And when you transfer these parameters into the design, you will find out all the sections calculated automatically. So every section is controlled, which means the section of the gate runner is getting smaller and smaller, which means the melted metal is getting accelerated all the time without the risky of the gas involvement into the casting cavity. And then you could just build or preview those kind of a design. And then you could just export the design in CAD format, or if you want to rebuild this kind of gating system in your CAD platforms, you could just export the sections. It depends on you. And of course, you could just keep going with the simulation function in CAD Designer. So this is about the free design function in a very short time and very easy to handle. So this is another case. We used the gating system design in CAD Designer to finish an industrial case. This is just to spend up about 30 minutes. And on the left side is an example finished by the NX, and it takes about 4 hours to do that. And you may still notice that the 4 hours work is not so good because the section area is not so controlled. But in our system, this is perfect. So CAD Designer makes better gating system, and of course make the gating system faster. So why we cannot make a perfect gating system? Because in the traditional CAD platform, there was no casting parameters controlled, because you have a lot of things to remind. If you just forget something, then you make a mistake. But in CAD Designer, those kind of parameters are calculated automatically and transferred automatically. So that's why we can provide high quality gating system, and also in a very short time. And based on this kind of design, we could check about the result in simulation. For example, this is two different designs. The first design is at the top, and the second is at the bottom. So we would check about that. The first plan, we could take a look here. The first plan is like this. Sorry, I'm using the, okay, that's, for the first plan, the feeding process is not so balanced, because you will find out on the left side, the metal runs more faster than the rest of the gating system, the gates. And at the bottom, you will find out this is much more balanced, because each frontier of the metal running at the same way, which means there should be no risky of L entrapments based on this new design. And on the right side, we could take a comparison about the shrinkage porosity distribution. And the second optimized plan is much more better than the first one. So this is about the comparison about two different design plans. And this is about the, this page shows some real case we have done in free design module, including some very complicated HPDC cases and also gravity casting cases. The gating system can be very complicated and in a 3D way. So you could just drag and drop the lines, and those sections will be controlled automatically. And we still provide another function we call template design. The template design is actually a database, a design database in CAD Designer. We stored some typical gating system in our database. So every time if you want to apply a typical gating system, you could just pick one and then make some modification about the parameters. For example, the location of the gating system and some the widths or the heights of the gating system, and then you could just build it in just 10 minutes. That's very easy way to create some similar gating systems. And this is all the templates in HPDC, and also we have another database in gravity casting. This is the gravity casting's templates in the software. Okay. Now we are talking about the cooling system. The cooling system is very important in HPDC industry because the cooling system helps make a rebalance about the temperature of the mold. So how to make the cooling system more efficiency and how to modify the cooling system will be very important to control the mold's temperature. The mold's temperature, if the mold's temperature is too high or too low, the casting properties, the casting's qualities should be quite different. So we provide a cooling channel design function in our software. You just draw those kind of lines, and then you can just build the cooling channel. And we still provide a heat balance guide, which means we could help you to calculate how many cooling channels for the casting. So you will get a total length of the cooling channel. And we still provide another one we call the fast cooling model, which is help us to find out how about the cooling channel, if this cooling channel works well for the given part. And we still can do a cooling affection analysis. Let's take a look at the next pages. This is a real case. You will find out that the green tubes are the cooling channels, and here is the casting part. You will notice the casting part with different colors in different region, and we could notice that in the yellow circled area, which means there is a heat spot, which means the cooling channel is not so, the cooling affection is not so good at this area. So what can we do for that? We could just modify the cooling channel. For example, you could add a new cooling channel around this area to modify, to optimize the cooling affection in this area. So this is a very convenient way to optimize your cooling channel and very easy to handle. You don't have to make another full die simulation about the fitting process and solidification process. You could just import the casting part and import the cooling channel, and you could make a fast analysis and fast optimization about the cooling channel. So this is what we can do in cooling channel analysis and optimization. Okay, so this page shows we have to win the business at the start point. The start point is actually about the design. If you have a good design, you will have a shorter time. If you have a good design, you will have a better quality in your manufacturing. So most of the industrial problems is from the design stage. So we need to focus our energy on the design stage. And let's take a look at the simulation in Geo-Designer. So this is the first case. We call it, this is an app from analysis. This case from Honda. There was a lot of different gating system design plans. For example, we have maybe 1, 2, 3, 4, 5. You have 5 different plans, but you don't know which one is better. So you could use this kind of use Geo-Designer CPI, which is the simulation module's name, to make an analysis about that. So let's take a look. This is another one. This case, we need to make a simulation in just 1 hour to find out which one is better among those 4 different plans. And here is a real case. How about the time consuming in those kind of a case? We received this product. This is a laptop frame, aluminum die casting. We received this data at about 1 p.m. and we used 40 minutes to finish the gating system design. And then we set up the model in 15 minutes and out in 2 hours. So this is the final picture. It's very fast. We could deliver it in a very short time for the plan, the design plan, and also the simulation result. And here is another case. From the casting part and CAD building and the simulation and check the results, no more than 3 hours. So in just one work day, you could just make 2 or more different design plane. So that's very convenient and fast for the industrial needs. And this is another picture done for the shrinkage porosity. This product is done in Taiwan, and we could notice that when we cut off the casting parts, you will find out a lot of shrinkage porosities. And this is the real photo, and on the right side is the simulation result, which help us to predict those kind of shrinkage porosity. And not only for the shrinkage porosity, we could still analysis about some typical industrial defects in casting. For example, the cold shots, the flow marks, and the gas entrapments. Those kind of defects raised by the fitting process. So this is some typical results we can do in Geo-Designer. Not only those kind of defects. We could also do a lot of other things. We do not show them all of them here. And then here is another case about in gravity casting. We finished the case in this is gravity casting, a flow process, and the simulation time should be longer than the HPDC because the process is longer. For example, the fitting process is finished in 10 seconds, but in HPDC, the fitting process is much more shorter. Okay, this is about the solidification results, comparison between these 2 different plans. Okay, so we just check them, and you will find out the shrinkage porosity is distributed on the outside of the casting, and we could make a section. You will find out those micro shrinkage porosity is quite similar with the real photo. And this is about the stress and deformation analysis in these 2 cases. You could get the average normal stress, the effective stress, and you could also analysis about the part deformation after the cooling and solidification process. So we could make a sum. We could make the fitting process, solidification process, and also the stress and deformation analysis in Geo-Designer CPI. Okay. And this page shows about the microstructure analysis. For example, we could analyze about the SDAS, and you could find out something. How about the phase transfer, and what about the mechanical properties in the microstructure analysis module? For example, the tensile stress and the yield stress is calculated in this kind of a module. And this is about the hardness distribution about the casting part. This module is very useful in the iron and steel casting industries. Okay, now let's take a look about the advanced module of the Cast Designer. On the right side is about we call the Cast Designer standard, which is help us to make the thermal and the flow simulation. And the standard module is actually repackaged into we call the Cast Designer LT. The LT version is just thermal and the flow simulation. Besides of this the standard or the LT version, we still provide advanced modules like the assembly module. This is a mesh module help you to make a full die mesh process. And we provide another CFD Solver, advanced CFD Solver, help you to make a higher accuracy simulation of the flow process. And the mechanical stress module help you to find out the deformation and the distribution of the stress after the cooling process. And the DCS is about the die compensation solver, which means you could just make a compensate about the casting based on the stress deformation. And the microstructure is introduced in last 3 pages. And also we provide a casting production module help you to optimize the manufacturing cycle. So this is all the advanced module and the basic module of Cast Designer. Now let's take a look at the mold assembly for permanent gravity casting industry. We could just mesh all the components together, including the die, the cores, the casting, the sleeve, all those stuff can be meshed together, and all the interface, the mesh nodes on the interface are all connected. That's very useful for the full die analysis. For example, if you want to considering about the time, for example, in the gravity casting cases, if you want to check the temperature distribution of the mold, then you need this module to check about the temperature of the mold. This is another case. We're considering we make the full mold simulation. So the first step is to assemble the mesh of the components together. And this is about the microstructure analysis. You could just pick the casting alloy, what's the type of the casting alloy, and then you could get all those microstructure information, like the yield stress, the hardness distribution, the SDS of the casting. Okay. Advanced CFD flow solver help us to get high quality simulation results in the feeding process or the flow process. This is based on the FVM method, and the basic module is based on the FEM solver. So that's different. That's different solver technologies. The FVM is much more better for the feeding process, but it costs you a lot of time. So this is an advanced module for the customer to purchase. In the basic packages, you use the FEM solver to check the simulation in a very short time. This is some a real case, the CFD Solver, the real case with the experiment. You will find out the CFD Solver is very good to calculate about the metal filling in high velocities. And this is another case, help us to predict the gas entrapment in the CFD Solver. Okay. And this case is about the stress and deformation analysis. It is very useful for you to predict how about the deformation. In this case, the wall of this casting part is deformation outwards about 0.6 millimeters, and this is the real photo. It's quite similar, and we could of course make a section to check about the deformation, and if the is quite small, you could amplify, you could enlarge the deformation in the post-processor to make it much more easier to observe. And this is another case in investment industry, the stress and deformation analysis. And now let's take a look at about the distortion composition solver. This solver should be based on the stress module because you must have a first round simulation about the deformation, and then you could make the compensation. So the compensation idea is quite simple. Let's take a look at this page. If the original casting shape is like this, it's totally vertical, the wall is totally, and the shape after casting process, you will find out it's outwards. And after the compensation, we could make the wall inwards. And after the casting, you will maybe the casting part will be deformed into the standard shape. So that's the concept about the compensation. We are applying the deformation in a reverse direction on a die shape. So this is what we have done in the solver, in a DCS solver. And here is a real picture. We could make a displacement analysis about the casting part. At the first out, you will find out a lot of airwear with a higher deformation. And after the compensation, you will find out this is the first round, the first iteration, and second iteration. You will find out most of the airwear with a lower deformation. So we could just make a lot of iterations to get a better results if this case is capable to do the compensation. Please notice that if you set a very high standard for the deformation, that will be not easy to find out a solution. So this is something you need to remember. Not all of the target can be reached if you input unrealistic requirements for the casting part. So when you finish the compensation, you will get a mesh of the casting part, and you could just export a mesh into your in STL format into your system to make a geometry rebuilding. Okay, so now we just remain the final module to introduce. This is about the production module. And what is casting production module? This is actually a module that helps us to optimize the cooling channel and the production cycle time, and to get a reasonable mold temperature and reasonable cycle time. And let's take a look at the real case. The left side picture about the thermal simulation. You will find out we have 12 points to test the temperature on the mold. And the left side is the simulation, and the right side is the actual testing. And this testing is finished in Japan, and we have make all those points in a plot, and you will find out the error between the real temperature and the simulation temperature. And what we are going to do in this case is that we should make sure the mold temperature is stable, and we need to make the casting part in a shorter cycle time. That will help us to increase the production rate. And in this case, the initial cycle time is about 86 seconds, and after the iteration and iteration calculation in this module, we have saved about 20 seconds. So that's amazing for the manufacturing, because you could produce more products with the same quality in the same time. So let's take a look at these pictures. On the left side, the first one is about the temperature after the casting ejection. So this is before the optimization. You will find out some place with higher temperatures in red color. And the second picture is about the casting temperature after ejection. And this is after the optimization. You will find out the temperature distribution is much more balanced than the original plan. And here is about the picture C is about a cooling channel, and we could make a cooling channel optimized in this module. We could optimize the HTC value of the cooling channel, and you would use the HTC value to recalculate about the water feedings velocities, and we could help the customer to control the mold temperature after the ejection based on this module, which means you get a more balanced mold temperature in a shorter cycle time. Okay, so this is another case. We just make 3 iterations. So we could just 3 iterations. The cycle time is at the first time the cycle time is about 110 seconds, and after 3 iterations, we could finish the gravity die casting manufacturing in just 74 seconds, and you could get the result about optimized cooling channel parameters. And then you could use this optimized cooling channel parameters to find out how to control your cooling channels, the water, or the water's velocities, and the cooling channels HTC for the manufacturing. And this is the process layout and sensor. We could add a lot of sensor on the casting part, check the temperature on this given place, and make sure all the optimization is under your requirements of this sensor points. Okay, so this is about CAS Designer. We all the major functions about in the product, and we just have a show you about the full module of CAS Designer, and we still have a light version. We call the CAS Designer LT, the light version. The light version is only focused on the simulation. which means we just integrate the simulation a module in the light version without all those other functions. So we could take a look about the light version, and this is about our now I'm going to show about the light version. Okay, so this is the light version of CAS Designer LT, and you could notice that this is the interface, and you would have basic functions about the casting process. Let's take a look. This is the CPI setup. When you import the model here, you could just make it into a mesh, and then you could just make a setup. For example, what we support is about the HPDC, high pressure die casting, low pressure die casting, and gravity casting industries. And you could just make a solidification and or the filling and solidification. It depends on you. And here is the object. We support the object type like the casting, the filter, installation, mold, and core. And we still provide a material database here. You can load the material database here. You will find out this is the molds category, and the steel, aluminum, and the copper. And the database is a little different with the standard version, because the standard version provides more material in the material manager. And for the boundary conditions, you could just apply the temperature, the heat transfer, the velocities. If you have a cooling channel, you could just implement a channel here, and you can use the zero velocity to fix the mode. And so this is about the CAS Designer Lite. This is quite simple and easy to use. And we could take a look about the result. Okay, I'm going to show about the results in our post-processor. Okay, this is a typical case of CAS Designer. We just have opened a module, and let's take a look at the filling process. So here is about the, let me switch to the beginning of the filling process. So the red color is about the metal, and the green colored area is the frontier of the material. So if you play the movie, you will find out the filling process step by step. And if you want to check about the air, we still provide a function we called the air entrapment. So you will find out this is the air. We just actually make a reverse. So when you are playing the video, you will find out there is something, some place with isolated a blue colored area. For example, this is about a gas. In this area, this is a gas entrapment here. And when you just keep going with the process, you will find out more risky area of the gas entrapments. And we could talk about the fill time. So this is about the fill time. If the area with with the green color, which means this area is filled earlier, and if this area, if it's in red, which means it's filled later, and sometimes we could find out a boundary like this. So let me take a look. So this is a boundary you can check in the filling time. So in the real case, there should be some risky of the flow marks. So that's a convenience way help us to find out the flow mark on the surface of the casting part. And let me take a look here, and you will also find flow marks like this. This is the shape. Okay. And we could still find some problem here. Okay, so that's a very easy and easy way to check about those kind of defects on the casting, on the final casting product. And let's take a look about the shrinkage porosity. So let me remove all the joints and go to the final stage. Go to the final stage, you will find out all the shrinkage porosity are generated, and there should be 4 regions with risky of shrinkage porosity, and the shrinkage porosity is measured in 5%. So if you input a lower value, you will find out should be more risky area. So 2%. 2%, which means it always shows the micro-porosities, and 5% always show you about the macro-porosities. Okay, so this is about the what we can do in Cast-Designer, and also what we can get from Cast-Designer. Okay, so is there any questions we could make a discussion here? So Barbara?
Yes, please let us know if you have any questions. There's a tab in the control panel where you can type them in. We're here. We'll stay we'll hang around for a few more minutes, see if you have any questions. In the meantime, I want to thank Dennis for this great overview of Cast-Designer. That was really fascinating, and I'm very happy to introduce a product that is specific for the casting industry, and it's so specific and comprehensive. I really I'm glad that you took your time to really present it so well for us today. So if you have any questions, let us know. We were here for another minute or two, and looks like Dennis is your man if you want to know any specific questions. So go ahead, don't be shy. All right, looks like no, the questions are not coming in, but here's what I'm going to do. I'm going to take the screen back and keep an eye for questions in case, you know, they come in. Well, you know, we'll be hanging out for a few more minutes. And I also, in the meantime, I want to thank you all for joining us today. And I want to show you the page where you'll be finding Cast-Designer on the Novedge's website. So go to novedge.com, and then you can look, you can type in Cast-Designer, or go to the brand page and look for C3P. an older product will show up. And you have all the option. You can have 1 month, 6 months, 1 year. You can look at the LT version or the Cast Designer non-LT. And you have a lot of option, and it's a great tool. I don't know what else to say. That, you know, Dennis explained it all. So Dennis, there are no questions. I also want to remind everyone that today, actually, we have been recording this presentation. So if you want to watch it again, just go on YouTube, Novedge channel, and we'll be there. And
Okay.
yeah, next week's webinar is about V-Ray for SketchUp, just a quick mention. And you can follow us on Facebook, Google+, and Twitter. And, you know, come check out our products, and especially the C3P line. The C3P is a new partner, and we're very pleased that they joined the Novedge team. Thank you very much, Dennis, and have a great day or night, everyone. Bye-bye.
Thank you, everyone. Bye-bye.